Hello everyone. Today we are going to discuss really interesting topic, permutation and combination. This is a mathematical concept, but since as you all know that in physics while deriving we often use these mathematical formulae. Whenever we are deriving huge and complex derivations, we make use of mathematical formulae, rules and various concepts. And this permutation and combination is one of them. Being a mathematical concept, we should know how to use it in physics. So today we are going to discuss what is permutation and combination all about and how do we use them in physics. The formula, the meaning, everything about it. So let's get started. The word permutation refers to arrangement, how we are arranging numbers or objects, whereas combination means formation of groups. Combination has nothing to do with arrangement or order, but permutation takes huge care of the order in which we are arranging the objects or numbers or anything. Now, as you can see in the picture, the person is inserting the ATM pin, and you know that ATM pin has 4 digits usually. So suppose a person tells to his friend that his ATM pin is a combination of 4 digits, which are 2, 4, 1 and 0. Now the person has only told the digits which are used, which are there in his ATM pin, but he has not told the exact pin. Okay, he has only told the digits involved. So he has told basically the combination. It's just the group of 4 numbers. He just told his friend that okay, his ATM pin is a combination of these 4 numbers, 2, 4, 1 and 0. But what is the actual pin? For that, his friend has to make some arrangements. He has to look, he has to make some permutations to actually get the correct pin. So suppose these are the numbers. So his friend might start making arrangements, different arrangements of these 4 numbers. What could these be? Let's see. Suppose he would start with 0, 1, 2, 4. Okay. Then he would say that okay, this is also possible, right? And then if we say do this thing 1, 4, then 0, 2, 4, 1 is also possible. 0, 4, 1, 2 and 0, 4, 2, 1 is also possible because he doesn't know the pin. He only knows the numbers, the 4 digits. So actually these 4 digits given, these are combination, just a combination of 4 numbers. But what is the actual pin? That could be anything. We don't know the actual pin. That would be some exact arrangement of these 4 numbers. And that his friend has to guess. So let's keep on making. Okay, fine. This is there. So these all are now, these are permutations. Okay, these are permutations because these are all different arrangements. See, no particular arrangement is matching with another one. This is different, this is different, this is different, all are different. So all the combinations, sorry, all the permutation that we are going to make, which is basically the combination of these 4 numbers, they all would be different. So combination is all in all the 4 numbers just taken in any form, and it really doesn't matter what is the order of the number. You have just picked 4 numbers and their order doesn't matter, but permutation cares about the order. So all these arrangement, you can see the order really matter. In this particular portion, 4 is at 1's place, 2 is at 10's place, 1 is at 100's place, and then here we have just swapped the 1's and 10's place numbers. So in this way we can make as many permutations as possible. So let's see what else could it be. Similarly, taking 1 to the thousands place, we can have these arrangements. See, first 0 is on hundreds place, then 2 is on hundreds place, then 4 is on hundreds place, and then we keep on swapping the numbers on ones and tens place. And then we can have 2 also at thousands place. So it could be like this, 2041. Then we can have 2104 or 2140. That is also possible, right? Then we can also have 2401, and we can also have 2410. Okay, and what else? We can have 4 at the thousands place also. So it's 4012, then 4021, then 4102, 4120, then 4201, 4210. So these are all the permutation, and maybe at one such permutation or for one such arrangement, that pin could be a correct one. So maybe at this particular, when he inserted the number like this, that first he inserted 4, then 0, then 1, and then 2, then the pin got accepted. So this came out to be the exact pin. But he tried all these arrangements. So his friend just gave him a combination of 4 numbers, that okay, fine, these 4 numbers are there. Maybe he must have forgotten, so he just couldn't remember. He could only remember the digits involved in the pin, but he forgot the order in which the digits were arranged. So he just simply told him all the 4 digits, and then he tried all the possible arrangements of these 4 numbers. And then obviously, of all the possible arrangement, one would be the correct pin, and suppose this is 4012 is the correct pin. So now you can see this 2410, that the digits he told him, that was simply, this thing was simply a combination. He just told combination of 4 numbers, that okay, those 4 numbers are in the pen. But all these arrangement that he made later on, they were permutations. So all this section belongs to the permutation portion. So this is basically the permutation side, okay, and that is the combination side. This is combination, and all these are permutation. So I hope you must have got the idea of what this permutation and combination means. Order is really important for permutation. See, 0124 is a different thing, 0142 is different. We know it's a different number. Okay, so arrangement really matter. But for combination, it simply means that you have picked 4 numbers, and whatever is the order, that really doesn't matter. In this way, we can understand permutation and combination in various forms. This was a particular example of ATM pin. In the same way, we can have number of persons sitting on a table or sitting in a row. So we can say that who is sitting on first bench, who is sitting on second, and so on. If we actually take care of the order, that who is sitting on which particular bench or chair, then that simply means we are talking of permutation. But when we say that okay, 4 people are sitting there on 4 chairs, then that simply means a combination. When we are not pinpointing who is who and who is sitting on which particular chair. Now let's discuss what is the formula that we actually use for permutation and combination. First, let's have a look at the definition of both these terms. Permutation refers to the arrangement. So now you should know what is the meaning of arrangement, okay, of n mutually distinguishable objects. Now, what is the meaning of mutually distinguishable? Distinguishable means differentiable. If you can differentiate between objects, okay, if we are talking of colored balls, so maybe one ball is red in color, another one is blue, green, yellow, and so on. So that means they are mutually distinguishable. You can identify and you can pick red ball out of the group of balls, or blue ball, green ball. You can actually identify each of the ball separately. But what if all the balls are red in color or all the balls are blue in color? Then it is very difficult to identify which ball you picked first or which ball you picked next. It could be the same ball or it could be different, because we don't know. All balls look alike. So in that case, they would be indistinguishable. But here, in case of permutation and combination, we prefer objects to be mutually distinguishable. It means they should be different from each other in some sense. Okay, so we can have n mutually distinguishable objects taking r at a time. It is not necessary that we have to pick all the n objects at a time. We can pick a few out of them. So it could be that, let's denote it by r, at a time, such that the order of their placement is taken into account, is taken into account. So this is important. See, the example we did here, the numbers, their order was really important because we were choosing the correct ATM pin. So that could be a particular, that could only be a particular sequence of number. If you change the sequence of number, your pin would be incorrect. So whether it is 0124 or is it 0142, it is different. So this is permutation, where we actually take care of the order in which the objects are arranged. Okay, then there comes combination, which is again, it refers to formation of groups of again n mutually distinguishable objects, because even if we are grouping, we want objects to be different in some aspect. Okay, and then by taking r objects at a time such that the order of their placement is not taken into account. So now we have just grouped the objects. Even if those are balls or marbles, we have just taken a few marbles. If there are 10, we have just taken them, and we have not bothered about the arrangement, that which marble is coming first. Okay, and then we can pick a few out of them. Suppose we have 10 marble, we can pick 3 out of them. But then it's just that if you are going to pick marble, you would just pick all 3 in one go, in by your hand. You would just pick in one go. So which one did you pick first, that really doesn't matter. You would have picked all 3 in your hand in just one go, spontaneously. So in that case, we call it combination. Okay, so whatever is the number of mutually distinguishable objects, which we denote by n, we can pick r out of them. Now let's come to the actual formula that we use. First, let's have a look at the formula for permutation. So here, see, this is NPK. P corresponds to permutation. So if we are bothering about the arrangement, about the order of the objects, then definitely we are talking of permutation. So P stands for permutation. Then N is the total number of objects, mutually distinguishable objects. Then K is the number of objects that we have selected. So sometimes we go for N and K, and sometimes we go for N and R. Okay, so but N always stand for total number of items in the sample, whatsoever the sample is of, but it's just the total number of items whatsoever are contained in that sample. And whether you talk of K or you talk of R, it is the subset, basically the number of items which you are selecting from the sample, which you are taking out. Like we said, that permutation is arrangement of n mutually distinguishable objects taking r at a time, taking care of the order as well. Okay, so here this thing is basically total is n, and how many are you selecting out of them, that stands for k. Now let's have a look at the right hand side. This is n factorial. Factorial, now you know what is factorial. It is the product of naturally descending numbers, the descending natural numbers. If you have 5, then it would be product of 5 into 4 into 3 into 2 into 1 till we obtain the last value, which is 0 factorial, which we often, whose value we use to be 1. So this is n factorial upon n minus k factorial. That means there were total n and you are picking k out of them. So whatever is left, see whatever is left behind, that would come in the denominator and you have to take the factorial of that. Okay. So this is for permutation. For combination, we use the symbol C. Again, n stands for the total size of the sample or total number of objects that you are taking, and K is the number of objects that you have selected out of the total number. So here the formula is n factorial, that means total objects, factorial of that, divided by n minus k, means the left behind. You have selected k out of n, okay, so what is left? Obviously n minus k. So the permutation, or you can say the factorial of left behind set into factorial of selected set. Instead of permutation, you can also write factorial. This is also important. You can use this thing because ultimately we are just finding factorial. Okay, and now you can see here that this is n factorial upon n minus k factorial, and this is n factorial upon n minus k factorial into k factorial. Here you can see this, right? And this is simply n factorial upon n minus k. That means this particular portion that we are talking of, let me just highlight this portion. This portion is nothing but permutation. Okay, this is the formula for permutation. So what we can do is, we can establish a relation between this NPK and NCK. And what is that? That is NCK. Okay. Sometimes, see, there are different ways to represent. Most of the time what we do, total number is written as superscript and the number that you are selecting out of that is written as subscript. Okay. So this, and then as you can see, this is the formula for permutation. So we can write NPK upon, this is K factorial. So this is the relation between combination and permutation. So this is also an important concept to remember. Okay, so this is simple to understand. All you have to remember is the formula of permutation and combination because they are almost similar. The only difference being that there is k factorial in the denominator in case of combination. Okay, so and that's the reason that we can say that the combination and permutation, they are both related. One more thing to remember is that any repetition is eliminated in combination. In permutation, each and every object is considered to be different from other, and also each and every possible arrangement is considered to be a new arrangement. Whatever whatever arrangement is possible, that is taken into permutation, whatever different arrangements are possible. But in combination, if we have objects, then the repetition is just not allowed, because if we say in permutation that we have taken two objects, one is A, another is B, okay, one time we are taking A first and B next as AB, and second time we are taking B first and A next, which would be BA. But all in all, we have taken A and B. So permutation would say that okay, there are two different arrangements, AB and BA. Okay, the order matters in which you are picking the objects. But according to combination, both mean the same. They say you have only picked two objects A and B, no matter in what order you have picked them, whether A comes first or B comes first. All in all, after all, it is just the object that matters, that we have picked A and B. So that's it. So that would combination would consider it to be as one possible or just as one identity, one step or one arrangement. But for permutation, two arrangements are there. See, you can see here that we have these symbols. When we play cards, we have the card which have heart symbol on it, then diamond, then spade and clubs are there. So now if we are going to make combination, suppose we have picked one card which has heart on it, and then the combination would be heart and another card that we are going to pick, that could be of diamond, spade and club. Okay, fine. So we have got one particular combination. And then suppose the card we picked was spade, then we have to see what is the another one. So it could be spade and club. Okay, you can see it's a new arrangement if I'm saying. So it is a new one. And then spade and diamond, this is also new. So combination would add it. But see now, spade and heart. Now this is not allowed. Why? Because it was already here. Heart and spade. We first picked heart and then picked spade. And here we first picked spade and then picked heart. That simply mean one and the same thing because combination doesn't take care of the order. Okay, so that's why any repetition would be eliminated. Similarly, if the first pick card is of diamond and second one is of spade, then that is also a problem because it already came here. Then diamond and club is fine because it has just appeared once here. It's the first time it is appearing here. Okay, then diamond and heart is also not allowed because this came here. Then similarly, if we have picked the club as our first card, then neither of these three are possible because see, if we go for club and diamond, then this is not allowed because we had diamond and club here. Then club and heart is not allowed because we had heart and club here. And club and spade is not allowed because we had spade and club here. So whatsoever is the order of the card, that really doesn't matter. Combination only takes care of what are you having, not in what order you are having. Combination will only take care of that you have two cards, one is spade, other is heart. But permutation would say you have two cards, but in what order? Permutation would take care of the order. It would ask whether you have spade first and heart next or heart first and spade next. So this is the thing. As you can see here, then in permutation we have these three alphabets A, B and C. Now whatever arrangements are possible, you can see them here, that for A, B, C, we can have A in the beginning, we can have B in the beginning, we can have C in the beginning. Now you can see for combination, this is the only combination. If combination talks of these alphabets, then it would say that okay, you have A, B and C, all three are different, it's fine, stop here, that's it. Because it doesn't take care of the order. It is only concerned with who is there in the group, not in what order. So that is the only one combination I would say. So just not combinations, but just one combination. But how many permutations are there? 6 permutations. Why? Because permutation take care of the order. So now whether you take A first or you take B first or you take C first, that matters. And even if you have taken A first, then who comes next? That is also important. Whether B comes next or C comes next. Then if you have taken B first, then who comes next? A comes next or C comes next? Then if you have taken C first, then who comes next? B comes next or A comes next? So all this order is really important for permutation. But for combination, the order has no importance. So it will only say that, okay, I'm concerned with who is there in the group. So it say, okay, one is A, one is B, another one is C. That's fine. So just one combination. But for one combination which has 3 objects, we have got 6 permutations. All right. So whenever in physics, most of the time we use these things, specifically when we talk of atoms and molecules, when we deal with statistical physics and thermodynamics, because we often say that how many atoms are there. Suppose there are a total of n atoms, and then half of the atoms have arranged somewhere, or we often say that if there is partition, there is a box and some partition is there, and we are throwing some particles into it. So in what way the particle would arrange themselves in that box, that really matters. So in that particular case, we make use of these permutation and combinations. So this one is a really good way to understand what does combination and permutation mean. Let's practice one example. So the question states that what is the number of permutation combination of 4 objects taking 2 at a time. So we have to find the permutation and combination for the same. So first write down what is your n and what is the r. Okay. So n total number of object is 4 and we have to select 2 at a time. Okay. Now the formula of this permutation is NPR is equal to n factorial upon r factorial. Okay, so just substitute the value and we get 4 factorial upon 2 factorial. Now you know how to solve factorial. We have this formula that whenever you have n factorial, that is equal to n into n minus 1 factorial. Okay, so this is the formula that we always use till we obtain the value 1. Alright, as we know that 0 factorial is 1. So this is also there. We have to use this. So now let's see what do we have. Till we obtain 1, so we are going to write 4 into 3 into, we can write 2 factorial because we have 2 factorial in the denominator, and we would simply cancel it out. So we have got 12 as our answer. So 12 are the permutations. And what about combination? So what is the formula for combination? That is NCR, which is n factorial upon the left out factorial and the selected factorial. So that means we would have 4 factorial upon 4 minus 2 factorial and 2 factorial. That is 4 factorial upon 2 factorial and 2 factorial. We can write it as 4 into 3 into 2 factorial, and in the denominator 1 2 factorial can be written as like this, and another one we would write as it is. So this gets cancelled and here this gets cancelled. So we have 6. So 6 combinations. And let's see whether this NCR and NPR satisfy the relation that we studied. What was that relation? This is the relation. Page number 4. That combination is equal to permutation upon the factorial of selected objects. So let's find if this is true or not. NCR should be equal to NPR upon R factorial. So our NCR is 6. So let's see, this is our 1, this is 2, and now just substitute the values. What is your NPR? That is 12. Okay. And what is R factorial? R factorial means 2 factorial. So that is 12 upon 2 into 1, and this is 6. So we have got 6, which is same as the NCR. So we have 2 is equal to 3. That means it is correct. So yes, this is 2 is equal to 3. Okay. So this is how we solve permutation and combination, and this is a very important mathematical concept, that we often use in deriving various derivations. So this is all for today. Thank you so much.